Somebody might wonder why in a periscope, why not use a mirror instead of using prisms? Because prisms, what they are doing is they yes, yeah, they can. So why not use a mirror instead of a prism? There are advantages, and the advantages are quite obvious. Here, in total internal reflection, um, entire light is reflected. There's no loss of energy, and is much brighter. So the image you see is much brighter. And here is because some part is like when it hits a mirror. So the mirror has got it's got a polish at the back. But what happens is the ray, some part is reflected obviously, but some will get refracted inside, and it will get absorbed also. So it's refracted and absorbed, and there's loss of energy, and this is less bright. So we don't use plain mirrors. If we can use, we will always use total internal reflection instead of mirror reflection. But we have to control something. Now that control, you can see, this only happens when it goes from a denser to a rarer medium. Now, how do this is achieved here? Like, what is he doing now? Let me show you what happens. This is the same thing, very similar to what I was showing you. The only difference is this: the incline. But you notice what is happening. There is a 90-degree angle, and there is a ray which hits the if this is a right angle triangle, if this is a right angle triangle, it is hitting the side at 90 degrees, and then it gets internally reflected on the hypotenuse. Now why does that happen? You see, it's because of the first it hits here, angle of incidence is zero here because it is along the normal. And if the angle of incidence is zero, because the ray is coming along with the normal, the angle of refraction will be zero because sin I by sin r is refracted. Now this is constant. So we get sin I is equal to n into sin r. So if this is zero, this is constant. This has to be zero. So it goes straight ahead, hits it here. Here, now you'll have to observe what is the angle here. If this is 90-degree, and if this was 90 and this was isosceles, like you can make out this is so this is 45 and this is 45. So if this is 45, so this will also be 45. And if this is 45, this will be 45. If this is because this is 90-degree, and now that is happening, this is actually hitting at an angle of incidence is greater than the critical angle. 45-degree is greater than the critical angle because with glass it is 41-degree. So it doesn't come out, it reflects. It will reflect at 45. And if it's coming out at 45, this is 90, this is 45, this is 45. I mean, this is 45, this is 45, this has to be 90. Again, it goes out straight. That's why it's coming in, hitting here, totally reflecting and going out. This is because of the geometry and angle of. So, this question I was asking you, what happens here? It hits here at I is equal to 0. It goes out, goes in, angle of reflection, no bending, hits here. Now, if this is 90, if this was 45 and this was 45, then this is 90. So, this will hit at 45 because angle sum, angle triangle is sum is 90. Then you make a 90, this thing a normal here. This will be 45. So, the angle of incidence is greater than 41. 45 is greater than 41. So it is greater than the critical angle. So it will reflect, totally internally reflect. It will reflect at 45 degrees because the angle of incidence was 45. And then it will go here. And because this is 45, this is 45, it will hit at 90. So it will go out straight because angle of incidence again is 0. So angle of reflection. So it comes out from one face and goes through the other face and it reflects at the hypotenuse in a right angle triangle. Similarly here, this is slightly different. It is hitting at 90-degree at the hypotenuse. So again, angle of incidence is 0. Angle of reflection will be 0. Refraction will be 0. It will go hit here. Now this is 90. This is 45. This is 90. So it again it hits at 45. So again, angle of incidence is equal to 45 and is greater than critical angle, it will reflect at 45. It will hit here. Now, this is 45, this is 90, so this is 45, this is 45. Again, it will reflect because it's greater than, it won't come out, and it will reflect, it won't come out, and then it will go here. Here it will, if this is 45, this is 45, this is 45, this is 90, it'll hit at I is equal to 0, it'll go straight. So what's the pattern? The pattern is if it's hitting perpendicularly one of the two faces of a right angle, it goes out of the other face. If it hits perpendicularly the hypotenuse, then it comes out of the same face. And that's what they're using here. You see here, if you see, this is that thing. The binoculars, they are using that hypotenuse hitting at hypotenuse. You see, this is the hypotenuse. And here is, it's, if you can make out, and um, so they have placed these, like, the ray comes here, it hits the hypotenuse, comes out of the hypotenuse, then they put the other, again, binoculars 90-degree, okay, so it again hits and comes out like this through the hypotenuse. There's a hypotenuse here, there's a hypotenuse there. I mean, this is pretty confusing, but there are two hypotenuse, just entering the hypotenuse and going out of the hypotenuse, entering the other hypotenuse and coming out of the other. And here it's hitting the side and coming out of the side. So you have to understand here, again hitting the hypotenuse, hitting the hypotenuse, you know, and comes out of the hypotenuse. So this is what happens in your cycle and reflectors and car reflectors. This is how they are made, total internal. Those reflectors at the back made up of, so this is the section of that. Did you understand?